Hey all, welcome back to my channel. So in today's video we are going to discuss about a very important topic in System Verilog, which is System Verilog process. Okay, so one thing I am going to tell you today, so the topics that I am going to upload from today, like from this session, what are the topics that I am going to upload in the further sessions. So all these are very important topics. Why? Because what are the topics that we have discussed until now, so all these topics are already present in Verilog, and we have discussed about their extended versions in case of System Verilog. Like for example, in case of Verilog we are having data types. In case of System Verilog also we are having data types. But in Verilog we are having only limited data types, like we are having int or integer or register net. So these are some limited data types in case of Verilog. But in case of System Verilog we are having many extended versions of it, like you are having short int, long int in case of in family, and you are having strings, and in case and also you are having some user defined data types like enum, struct. Okay, so we have all discussed about detail about these topics in our System Verilog sessions. And also, for example, if you have seen arrays, in case of Verilog, you have seen only single dimensional array, multi-dimensional array, or some what is the difference between some static and dynamic array. That's it. But in case of System Verilog, you have seen dynamic array. Again, in dynamic array, you have various categories like dynamic array, associative, and queues, and you have seen various methods that you will be using in case of all these arrays and queues. Right? So, what have you seen until now are only the extended versions of Verilog. Okay, but what are the things that you're going to see from this from next sessions? They all will be the new introductions in System Verilog, because as you already know that System Verilog is mainly used for verification. Okay, so in case of verification, what is the main thing we need is we need reusing purposes. We have introduced System Verilog in order to have various things like reusing, okay, restructuring. So in order to avail all these functionalities like reusing, restructuring, repurposing, so in order to introduce all these things, we have introduced various concepts in System Verilog. Like if you see, in the next upcoming topics we are going to discuss about oops topics, and then randomization, and then assertion, and then coverage. So all these topics, if you see, they are newly introduced in System Verilog. Until now, you have not studied about all these topics in Verilog. Okay, so that is why the topics from that I'm going to upload from today are very important when it comes to verification domain. Okay, as you already know that if you are following me, that I am a design and verification engine trainer, and I'll be training students on this design and verification courses. And if you want to enter into this DV domain, you should compulsorily know about these courses like Verilog, System Verilog, and UVM. You should just not know basics, but you should know up to bottom. Like you should know, if it is from 1 on 10, you should know up to all topics, 10 on 10 topics on this System Verilog and UVM, in order to survive in this DV field. Okay, so if you are new to my channel, consider subscribing my channel and hit on the notification or bell also, so that as soon as I upload the video you will get the notification. Okay, so let's not waste any more time. Today we are going to discuss about System Verilog process. Okay, before going into what is the System Verilog process and all, okay, so in order to make you understand simply, I will just say a small example for this. What is the use of introducing this System Verilog process? Okay, so in case of Verilog, you have seen some blocks which run parallelly. What are those blocks? Initial and always block. Okay, since if you already know about Verilog, okay, you know about this initial and always blocks. If you don't know about Verilog and you are seeing this new about this if this video is new to you, I link that initial and always blocks in a video in the description box. You can go check it out there. Okay, and also I have created a separate playlist for Verilog as well as System Verilog and codes also. Okay, I'll link that playlist links also in the description box, so that it will be easy for you to check all the videos at one spot, right? So coming to Verilog, in Verilog you are having two blocks like initial and always block which will be running parallelly. That means which will be running it parallelly or zero time. So what does this mean? For example, if I am taking a four initial blocks, okay, in my code, if I am writing four initial blocks, okay, so within my four initial blocks, if within this initial block I have begin and I have written some two statements like statement 1 and statement 2. Again in this initial block I have written some again three statements 1 2 3. Again within this initial block I have written some three more statements. In this I have written some two statements. Now in this way if I am writing four initial blocks or always blocks also, either initial or always, both of this, okay, so basically if you come to initial you will be, it is, since it is non synthesizable, it can be used in test benches, and always is synthesizable, so it can be used in like RTLs. Okay, so basically either initial or always block both will be running at zero time. Zero time means, that means when you are running this particular code, all these initial blocks will be starting at zero time interval. Okay, so based on the execution of the statements, okay, that means if this particular statement is not having any delay, then they will also be executed at zero time. If this particular statement is having delays, then based on the delay the statements will be executed. Okay, even though the statements are being executed based on the delays, but the starting of these blocks will be starting at zero time. So all the four parallelly they will be starting at zero time. Okay, so this is the thing called process in System Verilog. Okay, so basically in Verilog you are having some blocks like initial and always block which will be running at zero time interval. It is fine, but this is not enough in System Verilog. Okay, because you already know System Verilog is much more advanced in case, and it is having much more advanced features, and it was introduced for verification basically, and also verification is very important in case of any domain. Okay, in case of VLSI domain at least, verification is very important and it plays a major role while you are designing any circuit. Okay, because even though the designer will be writing the RTL code to you, it's a verification engineer who will be checking out the bugs, and it will be given again if there is any bug in that particular, in your particular code, it is again sent to the design engineer in order to check over that and all. Okay, so this process will be continuing continuously until you will achieve a bug free design. So in case of where when you are particularly creating a language for this verification, it should have many much more versions than that of Verilog, because as I already told you, we are having in System Verilog, or we are mainly achieving for reusing or repurposing conditions. So in order to achieve such scenarios you should have a language which is much more advanced than that of Verilog. So that is why System Verilog was introduced. Okay, so basically what are the things that we are using in Verilog like initial and always blocks? This is not enough. Okay, this parallelity, this concurrent execution is not enough in System Verilog, which is why it has introduced a concept called process. Process is nothing but for example, if you are writing something within if you are writing some group of statements within a block, okay, for example if you are writing within some block, so this block is known as process. Okay, either we'll call it as process or thread, anything can be called, either it is thread. So mostly if you see in any websites also you will find this name as threads. Okay, right, so a process is also called as thread, which is nothing but a piece of code that executed in a separate entity. Separate entity means if you are writing some four threads, that means you are writing some four processes where the four processes will be executed parallelly. That means all the four processes will be starting at zero time interval only. So this is about the System Verilog process. So in System Verilog, apart from initial and always blocks, just we have seen in Verilog, we have introduced a much more advanced versions which is fork join threads. in System Verilog. So this fork join threads will be running in parallel. Okay, and again in this fork join threads it is categorized into three types. Like one is fork join, okay, another is fork join any, and third one is fork join none. Okay, so if you see these three kinds, like fork join any, fork join none, so all these three types of processes will be working differently. Okay, so in this sessions, in the upcoming sessions, we are going to see about what is this fork join, what is the fork join any, and what is fork join none. Okay, we'll be seeing one by one how the execution of the statements within this fork join will be done, how the execution of the statements within fork join any will be done, how the execution of the statement within fork join none will be done. Clear? Yes. So this is about system Verilog processes, in which in today's topic we are going to discuss about fork join. Okay, so fork join concept of system Verilog actually enables concurrent execution of each of its statements. Okay, just like as I told you. So every statement that you are writing within this fork join, all the things will be even though they are executed sequentially. Like if you are using some three or four fork joins within the fork join, if you are using some three or four threads, so all the threads will be run parallelly. Okay, even though you don't understand about how we are going to write it and all, don't worry, because I'll be showing clearly about this with example to you, right? So this feature, as I told you, mainly this system Verilog was introduced in order to know about system Verilog test benches, in order to make their use in system Verilog test benches. Okay, so System Verilog came up with new and advanced flavors of fork join construct. Like as I told you, again in fork join you are having some more categories like fork join any and fork join none. We also see about all those things. Okay, so let me explain this with a small presentation for you so that it will be easily understood for you. Okay, for example, right, you are writing some statements. Okay, so this is my first statement, so this is my particular code. Let us think this is my particular code. Okay, like some module, within module and n module you are writing some statements. Okay, if you see the statement, this is my statement 1, this is my statement 2, and this is my fork join. Within the fork join I am writing some three processes. Okay, three processes or three threads. That means here each process can contain one or two or three statements again. Like two or three statements. Let us consider two or three statements in each process. Okay, and then third statement and then fourth statement. Okay, is it clear for you? And also one more thing, if you don't understand any concept, please don't hesitate to ask me, because since this is not an on live class, okay, I can only give you the uploaded session. So that is why if you are having any doubts, please don't hesitate to ask in any of my social media handles, or you can ping me in the comment box also. Okay, those who already ping me, you already know that I will definitely respond to your questions immediately. And even though if I'm having it like 2 or 3 days of time also, I will definitely answer your questions. Okay, so don't worry about your doubts, please consider asking your doubts if you are having any. Okay, and also you can join in my Telegram channel in order to know daily updates about all these things. Okay, so this is about the thing, like statement 3 and statement 4. Okay, now when the execution of statement 2 and statement 1 and statement 2 is done, and when it is entering into fork join, okay, that means here if you see yellow color completed means that the execution is done. Okay, that means statement 1 and statement 2 is done and it has entered into fork join. Okay, so if you see, the length of this is considered as, for example, let us consider the length of this is nothing but delay. Okay, so if you see, first thing, the process 2 is completed. Okay, so first process 2 is completed, and then the process 1 is completed, and then the process 3 is completed. Okay, so until the process within fork join is completed, it won't come out of the statement 3 won't be executed. If you see here, okay, after completion of 1 and 2, In order to make the statement 3 completed, all the statements within the fork join should be completed. Then only the statement 3 will be start to execute. If you see here, since all the process within the fork join is executed, then the statement 3 is starting to execute. And after statement 3, then statement 4 is executed. So in this way the fork join. That means when you are writing any process or any statements within the fork join, okay, until all the statements are being executed in the fork join, the compiler won't be coming out of that fork join. Okay, this is the thing. So let me show you some example for this, like module fork join example. Okay, if you see here, within initial and begin, I have written the fork. Okay, just see this. This is my fork and this is my join. Okay, so that means this is the end of fork join, right? After fork join, I have written one display. Clear? So within this fork join, I am writing three processes. If you see, this is my first process, okay, and then this is my second process, and then this is my third process. So as I told you, within the process you can have any number of statements. So how can you know that this is first process? Like whatever you are writing within begin and end, that is considered as one process. Okay. So here if you see, within in the process, the first display statement is not having any delay. So it is at 0 time. And then the second display is having 10 time units of delay. Similarly, within this begin, it is not having any delay, so it is at 0 delay. Now the second display is having 15 time units delay. Similarly, the third thing, in the third process, it is having 0 delay, and this is 20 time units of delay. Okay, and then even though this is not having any delay, if you see here, after the fork join, if you see the display statement A, it is not having any delay, so this should also actually work at 0 time delay. But now let us see what is happening. If you see here, within the fork join, what are the processes that are being executed? If you see, what are the things that are at 0 time delay? Like if you see, process A started at time, process B started at time, process C. So process A started at time, process B started, process C. So these three display statements are being executed because they started at 0 time interval. Now what is the next thing? If you see here, then comes after 0, you will be having 10 time units delay. So the process A will be executed first, and then comes 15. So process B will be executed, and then comes 20. So process C will be executed. Now if you see, after all the things in the particular fork and join is executed, then only the fork will be ending, then only the compiler will be coming out of the fork join, and then at that particular 10-20 time units only the fork join completed at time t. So this display will be executed at 20 time units of delay. Okay, clear? So this is about the fork join example. If you see in this example, there are three process ABC, even though all started at same time. So based on the delay, process A is executed at 10, process B is executed at 15, process C. That is parallel. Hope it is clear for you. If you are still having any doubts, you can ask me. This is about execution of fork and join. Okay, so in the next session we will be going to discuss about fork join any and fork join none also. Okay, so if you like my explanation, consider subscribing my channel and hit on the notification bell also. Also please do like, share and comment on these videos. Okay, thank you.